Yeah, it's the same, but it's cool. This is y is equal to root x, and this is y is equal to x squared, part of those two functions. And they intersect, they give us the intersection, which is nice. You could find that sometimes, if required, is 1, 1. And they're saying, right, if I rotated that around the x-axis in a full rotation, that would create quite an interesting shape, wouldn't it? And they're saying, what's the volume of that shape? So it's like a, what would it be like? I don't know. It's like a flower or something. Yeah, it's like some strange bowl. It's definitely it's going to be like, it's like, yes, this kind of bowl, but it's a bowl that's in 1 dimension or 2 dimensions and 3 dimensions. This is full. That's a pretty bad diagram. But yeah, you can imagine it. Yeah, it's that going around. Okay, so could we find that volume? And yes, the same thing, because we can get the area between two functions straightforward, and we can get the volume of revolution around the x-axis. So we just combine those two things. So we integrate what then? We integrate one function, take away the other function for area between the two. But now we need to square the functions. And it works in the exact same way. Fx squared, take away gx squared times pi will give us the volume of those revolutions. So the one function squared, take away, because you get one volume, you take away the other volume, and it gives you the volume in between them. All right, so with these functions, these are very straightforward functions. This function is above, so it will sit in this position. Root x squared minus x squared, x squared squared, not x squared, x squared squared, with respect to the bounds of, I think on this, we go from 0 up to 1.
Sure.
Yeah.
Does it matter if we do gx minus fx?
What do you think will happen?
Like, would it be the opposite area?
You would get negative.
Would it be?
Yeah, you should get the negative area, yeah.
Oh, which doesn't make sense.
Well, a bit like when we did the one in the starter. When you get the negative area, if you're dealing with the y-axis and your shape is over this side, you get a negative area. If you deal with the x-axis and your shape is on this side, you're going to get a negative area. So you either take that into account at the start and just put a negative before your integration, or you take it into account at the end where you go, oh, I got a negative answer. Because it's on this side of the line. Okay. All right, so let's square this out. So we get x minus x squared squared, which is x to the power 4, I think. I still haven't integrated it yet. I'm still going to do that in a second. So I've just squared both of them. Does that make sense? Yep. And now I'll integrate. So I get x squared over 2 minus x5 over 5. And I'm going to deal with the pi at the end. And sub in 1, sub in 0. This one's quite straightforward. I have a half and 1/2 minus 1/5 minus 0, I think, which is 3/10, yeah. 3 pi over 10 units cubed units, because we're, yes.
Why don't you subtract the functions first and then square that? Why do you square the functions and then...
Well, I think we're doing order of operations at this stage, aren't we? Where any squares must be done before we subtract. Because, you can think about it. If I have 4 squared, take away 3 squared, is that 1 squared?
What do you mean? Put the square on the outside of the...
Yeah, why?
No, well, it's for this reason. Each function's, you're getting the volume separately of one function, the volume separately of the other function. You're subtracting it, so you have to do it this way. You can't...
How can you get volume